Howdy everyone, in this video we're going to be covering assemblies in Onshape. So first with the assemblies, it's these sample parts, which I will link in an assignment for everyone doing this like through IQ Robotics. Everyone else, I just cat up some parts similar to these. I have a little crank, a cylinder, this cube with a few holes in it, this hexagon that I just swept around, a little link, a slot, and then a part with like a grid of subparts. So to insert the parts, you're going to click right here, Insert, in your assembly, and you can either select from a parts studio, you can choose to insert individual parts by clicking in here, or the entire parts studio by clicking there. So now we have all of those parts here. You can also insert other assemblies. I don't have any right now. Or you can go to other documents, like this Sketch Basics document, and then you can create a version and then insert the parts from it, which it'll still generate the previews. Or you can even go to like public documents and look up for a specific part, or like your teams, the classroom, lots of different ways you can insert the parts. There's also standard content, which is just like general parts like screws, O-rings, washers, pins, all of that, which if you need something specific and you know like the standard, you can go and look in here and find it. But that's more of just if you need a specific part, and you can also just insert a step file through importing, which is right here. You can import files. There's also a few other things for like organizing your Onshape documents, which I will go over later on, probably next week. So there's a mate connector, which just builds in a connector for you wherever you want it to be. So like you can put it here, and you can also like realign it to like change its orientation or move it, translate it. And this allows you to connect stuff in a lot of different ways. For all these demonstrations, you don't really need the mate connector, because instead of using mate connector and putting it in this place, you can also just select the geometry features and it will automatically make the mate connector. So the first type of mate is a fastened mate, and that's just a rigid connection. So whenever you select the two parts, they'll join together. It will move the first part to the second part, and then you can reorient the second axis, which just rotates it in place. As you can see, the cube's rotating because of this, or you can flip the axis so it goes which way it's connecting. There's also offset, which just allows you to change exactly where it goes. And then you can rotate about one of the axes. And then there's like a simulation connection, which is how load is transferred between the instances. This is mainly for the like simulation stuff, which will be covered later. And you can also click solve, which if there's multiple mates, it'll just simulate all of them at the end. Then you can animate degrees of freedom. There are none in a fastened mate. So now it's just locked in place. And if I move them around, they move together. So the next mate we're going to cover is the revolute mate. And for this, what it will do is it locks it in place, but allows it to rotate. So now if I simulate degrees of freedom, you can see it spins around. And for any mate with degrees of freedom, there's also this thing called limits, which you can change the like minimum and maximum angle. So now, see, it'll only go a certain amount. And this allows you to change how much it goes each time. And now they're locked together. And if you notice, whenever I'm moving one, they're both moving. But if I want to test out this rotating thing, I'm going to right click here and fix this in place. That locks the part in place, which means now that part can't move, and all of the mates based on it will allow you to move parts around. So the next mate is a slider mate, which it's similar to the revolute mate, but instead of allowing it to rotate, it allows it to slide in and out. So now, once again, you can set the limits for the maximum and minimum. But if we look at this, now it slides, but it does not rotate no matter how much I try. And if you set limits, you could have it only be able to go like within a certain range. Next up, skipping over planar mate for now, just because it kind of makes more sense, is the cylindrical mate, which this one allows it to both rotate and rotate and slide. So now we go here, I can spin it around and slide it in and out, and you can put limits on both. So if I put limits, I can make it on the Z height and the Z angle. And then if you animate degrees of freedom, it shows you it can go like that. And then you can also do these with like non-cylindrical parts. So for instance, I can do a revolute mate between like this corner and this corner. And then we'll flip this over. So it's like this. And now this part can spin around there. So this physically wouldn't really make sense, but if you're doing like a test part or something and you wanted to have it locked like this, you could. Or if you wanted to like simulate a coding feature that hard stops it there. Well, stops because it's code. So next up is the planar mate, which once again, you can select whatever mate connectors you want. Just be careful to look at what orientation it is. So if you have noticed so far, whenever you put the mate connector, you see little X, Y, and Z. The blue is Z. I believe the red is X and the green is Y. And that just selects like what orientation it is. And then with the planar mate, it just stays in plane. You can also do offsets. So that'll like make it in plane, but just at a different height. And then there's limits again, more limits with this because it has more degrees of freedom. And then once again, you can animate it. And now, so you can see I can move around, but I can't move it down. It looks like I'm moving it down, but I'm not. It's just moving back. So like when it's perfect on the side, can't move it up or down at all. And whenever you are at an angle, it will actually move it at the angle. So it's still perfectly parallel. It just looks like it isn't. And you can see it moves so far forward because that's what you need to get to make it look parallel, or well, look like it's moving down just with that slight angle. Next up, we have the pin slot mate. So I'm just going to fix this in place, and it will give you a warning, more than one part fixed. If you have like all of your parts connected and have more than one part fixed, it generally isn't great. Sometimes it makes sense for like testing and stuff, which is why it allows you to do it, but it can cause issues with over constraining. So now we're going to do a pin slot mate, and then what you do is you select that mate connector, and then this one. And then if we animate the degrees of freedom, we can see it's going this way, and you really want it to rotate. So now this is the correct like direction, and it can move along like a slot, and it can rotate, but it can't move side to side. It can only move in this direction. And how you'd fix it in this area is just setting limits to it, which I'll go over that when we're doing like multiple parts together. But yeah, then there's a ball mate, which is just like a ball and joint connector. So this crank is really nice because it shows the rotation as well as being able to move. But we'll select here, and then you can see the limit is just the angle, like the cone angle. And if I animate degrees of freedom, it can go all over and rotate, but it still keeps these two mate connectors in the same spot. Which This is really nice for like certain features, especially if tolerance is off in your CAD somehow and you get it kind of skew. The ball joints can work really well for keeping two components like right there if you can't actually keep them together. Then the last of these like kind of the normal mates is the parallel one, which just means they stay at the same angle. So I'm gonna unfix the slot and you can see can't move it around. I can even select it if I try to spin it. Oh, I deleted the mate. But now you can see whenever it goes, it'll snap to parallel. Check. There. I won't delete the mate this time, I promise. So now if you try to angle it, it won't angle because it would no longer be parallel, but you can rotate it. So those are the main mates that are used. There's also a tangent mate, which just kind of, it like keeps parts tangent, obviously. So see it's tangent to this edge. It can also rotate as long as it maintains its tangency. I don't really use this one that often, but it does have its uses, especially if you're like two gears or something that are rolling along each other and you want to keep them together. Tangent mate is great for that. The next, and this is a newer one, but I really do like it, is the width mate. And let's see, you select like the two edges of one part, and then you select the two like other tabs. This is where it's connected to. And if you notice now, it's not in this part, but what we can do now is this one pretty much always combines with a cylinder mate or cylindrical mate. It could also be like a slider mate if you didn't want it to rotate. But with the cylindrical mate, I solve it, and now it is perfectly in the middle. So if I close out of this, add it, you can see it can rotate, but it can't move up or down, and the cylindrical mate keeps it in this area. And also, quick note on measuring. There isn't a specific measure tool in the assemblies because you just click on the two faces and you see the measurement down here. So we see our parallel distance is 0.750. You can see a bunch of other specific stuff, change like what units, and this just changes it whenever you select it here. And then units are obviously there. There's also analysis tools and mass and section properties. Interference to this just shows if there are any like conflicting areas. And then zebra stripes just makes everything with zebra stripes so you can kind of see the parts. It's kind of goofy, but yeah, I think it's mainly for curvature, so you can see if curvature is like consistent. But as you can see, it was 0.75 here. Go back to inches, making close this out, we see 0.75 here. Then we go to the other side, 0.75 as well. So no matter what these sizes are, it'll keep it perfectly centered. So you can even change this length with like a configurable part, and it centers it nicely. Then next up we have group, which this one is really nice if you have like a sub-assembly that's a bunch of parts, but they don't move. What group does is it's group, or sometimes called a rigid group. I need to unfix this to show you, but it just keeps all of these together at the same relative positions. So it's as if they're one like solid part now. Next up, there's snap mode, which is kind of just, you can select mate connectors and like grab stuff, drag it together, or if you drag it up, it will snap to a mate, which I literally never use this. You can if you have like a lot of easy parts to assemble, but it's just kind of hard to do sometimes, and I just like my mates. And then once you get here, you can select the type of mate pretty easily. I didn't confirm the mate because I didn't want to. And there's also show mates mode. So if you have mates between like these two parts here, when you hover over it and the show mates mode, it'll show that mate, which is nice if you need to do some editing with the mate. There's also replicate. I'll show that in just a second. So if we go over to this big square thing, you can see we have this little square and you want it to fill all of these holes. There's two ways to do it. The really cool one is replicate, so I'm going to show you all that one. You can also do a linear pattern and just match it up, but then it isn't dynamic. So I'm going to create the mate here between these two. Then I'm going to do a replicate. So instances, and then I'm going to select this. It'll automatically select and match faces. There's also match faces and features and match individual faces. So a few options to do it, and then part to find matches in. Oh wait, I did this wrong. You're supposed to select the small thing, the one that's going to be patterned multiple times. And if you look, it'll automatically fill all of those matching faces. And now with like 2 mates, I have all of these done, which is super nice and really fast. There's also, next feature is replace instance. And this kind of just replaces it with something else. In general, this causes mate errors. So like, I generally just delete stuff, but I believe if it has like the exact same feature, it sometimes matches up. Then there's also the assembly linear pattern. And the best part is you can also linear pattern like sub-assemblies. So I can do that, and then like the replicate as well, or just select all of these. And then you select a direction. Let's do 8. That was not long enough. Okay. 16. Maybe this part's bigger than I expected. But what it'll allow you to do is just make multiple parts. You can do equal spacing, which this just means this is the total distance traveled, and they're all within the distance. You can also do centered, so they go on the other side as well, and then do a second direction, which allows you to do like a grid of them. So this is how you would do these little squares without the replicate feature, but I really like the replicate feature. You can even do a third direction. So make like a cube. And then you can see all of this is here, and it's all under this linear pattern, so you can see all of the parts in here. You can tell there's a lot of parts of each, so doing that by hand would take absolutely forever. Delete there, just to clear it up a bit. Then it has the same thing with a circular pattern. So you can highlight all of this, access to the pattern. Let's just say we want to do it like here. You can get there. You could do 4. It makes this nice grid. You could even do like 5, and it'll overlap. And then centered just means it would go on both sides, but it's going 360 degrees. We go 180. Now we can see there's more of them. But yeah, I think if we go like 90 and then do 3 and center it. Yeah, it does stuff sometimes. But this will just, it's better if you have like bigger parts that you want to do a circular pattern for. This square thing doesn't make the most sense. It's just what I have for demonstration. Then next up we have our relations. So this just takes our mates and like kind of syncs them up. So first one is a gear relation. So I'm going to just do a revolute mate, select here, and put it in our little link thing here. Flip it up, there. We have our first revolute. We'll fix this in place. Then we're going to do a replicate. Wait, dang it, there. I always forget to do that one. So now we're going to do our show mates mode so we can see the mates and the parts. And then we'll do our correlation and we'll just, it's not showing mates in there. Okay, we can select our Revolute mate and then in our replicate 2, it shows the mate feature here. So now this is a 1-to-1 ratio. If we spin one, the other spins. If we want them to go the same way, we can reverse the direction. Just depends on how the mates are formed. So now they're always going to be linked up. We can even change the ratio. So if you have 2 different sized gears, they'll spin at different rates. This is really cool where you can actually animate the joint. And then it'll like accurately show it going through. Animating is very nice for demonstration purposes. Next up, we also have the rack and pinion relation. So let's see. Let's do a pin slot mate. Select the top of here. And this right here. Now animate it. Let's see. Okay, yes. I believe that is what we want. I select the edge. Oops. At least I believe I did. Yes. Slot 1. I actually wanted to select like this. And now this will keep it. Rewind second axis. Yes, this is the way we want it. Flip primary axis there. So now we have our pin slot. And now we can do a rack and pinion relation. So we want to select our Revolute. And then our pin slot mate. It will let us. It might have to be a slider mate for this. Yeah, it actually does have to be a slider mate. So in fact, we will do a slider mate. I think that should work. Or I believe planar mates also work. Let's test that out. Do a planar mate there. No, still not over constrained. Edit this. Yes. You just have to select the degree of freedom. Does that work with pin slot mates? No, it does not. Or does it? Oh yeah. You just have to select the degree of freedom for that mate. And then now we rotate, it will move along. And for this, we will just do a little animation again, because it is so much easier to see in the animation. So as you can see, as it's spinning, this will move over, moves back. It's just a rack and pinion. And then also if we slide this, those will rotate as well. Next up, there's a screw relation, which is very similar. It's just a screw. So let's go back to here. This is fastened mate. Let's change it. I still want that part there. We can even do it in here, which this is curved, so technically this wouldn't be physically possible, but that does not affect us in CAD. A very important thing to remember, not everything that works in CAD will work physically, but if we do a screw relation, let's see. Yes, so with the screw relation, actually this is really bad to see with the cylinder here. So let's see. How do I do replicate? Replace instance. pin placement component, replace it with the crank. As you can see, yeah, it does mess up the joint. This generally happens, but you can go back and edit it. It just can't find the matching mate connector. So if two parts are like a replacement, like a newer version, it would work. So now, as you can see, when this rotates, it moves. Or if we move it in, it should theoretically rotate. Now we can show that by animating the degree of freedom we want to animate. We can do the sliding. So now it'll go in and out and show it rotating. Or if you show like the rotating one, it'll do the same thing because they're mechanically linked. Then there's also a linear relationship, which is just a like linear, what's it called? It's like a linear slide or something. It goes out the same. This one is different, so the replicate won't work because it's kind of goofy. Just because this, due to the curve and stuff, is split into two parts instead of one continuous circle, but it does work on the bottom. So these aren't the same feature, but they do match close enough for it. And then if we do a linear relation, we can go select cylindrical, and because it's a linear one, it automatically knows this is going to be the like in and out degree of freedom. So now if we slide this in, as you can see, they're going the wrong way. So you just reverse it. Or maybe you want it to be like that. But now the two parts move together. And this is really cool because you can still animate the mate. So let's just hover, animate cylindrical 1. And now we can see they move together. You can also change the amount of steps, which makes it go faster or slower. So like with 100, it's fairly fast. So those are all of the mates and features. There's also simulation stuff, which will be in a future video. Then there's display states, which is kind of just how the parts are organized. So like test. And then now if I like move some parts around, I can update this display state, or you can like make more and then like T2, move some parts around, and I can go back to test. Oh, why is it not working? I don't use display states often, sorry. So T2's that one. It should update back to the position. Or it might just be with meets and stuff. But honestly, as opposed to display states, it's much nicer to configure your part studio. Display states are just like one thing, but with configuration, you can get it to lock into certain positions and have degrees of freedom. Oh yeah, display state, sorry, display state is what's visible. Named positions is whenever it goes to a certain position. So named position 1, let's see. Okay, we have named position 1. Now we can move around parts, add named position, done, and then apply, and we'll go back. Yes, display states is just what's like visible. So I could make a new one like hi, and then let's say just hide a few parts. There, I just got the two confused. Update hi. Now I can go back to test and they're visible. I go to hi and they're hidden. Then again, I don't really use this often. It can be helpful in certain circumstances, like if you're just playing an individual piece of the puzzle, but not the most. Then there's also simulations, which I'll cover in the future, variables, and then this is where you actually have the Vex library, which if you install in the first video, it'll be right here, and you can insert parts from here. So you can insert the Part Studio, and now, let's see, right here, you have that part, and you can just select anything from here. There's also a bill of materials, which just shows all of the different parts. If they have the information like the part number and description, then it'll actually show that. None of my parts do, just the one I inserted from the Vex library does. And it shows quantity as well, which is really nice. You can also do like structured, which is if you have assemblies, you can add columns and stuff. So the columns is where I have like the name for every part. This is really useful for 3D printing or ordering parts or just documentation in general. And then my favorite feature, Create Part Studio in Context. I almost always just select the origin. You can also select a mate connector on a part though. Or well, yeah, you have to make the mate connector though. But I just select the origin, and this allows you to actually edit the parts in context. The most important part with this though is you do have to use like some sort of feature in order to keep that assembly context whenever you leave the tab. You can also turn off the assembly context in this little side menu. And then there's a few things you can do with like updating and editing the context. That takes a bit more to do. So I do also want to show you, you can go in and instead of doing the Part Studio, there's also Edit and Context, which now pulls everything in. Once again, these are all the same parts, so it doesn't really help us, but everything is relative to the position of this cube. So now I could like modify this cube using other parts. And those are all of the main features of it. And then once again, if you do nothing with it and leave the tab, it disappears when you come back. So I can just do a quick example of like actually editing in context, which would be like, say we had another part we wanted to mate something to. So like we're going to connect the cylinder to the cube. So now we're going to go to our assembly. I also do like to organize the tabs in a certain way. I typically put my assemblies on like the far left, whatever the main assembly is. And then if I have like a sub-assembly, it's right next to its Part Studio. Organization, very nice, very important. But we're going to insert this circle here. I'm just going to say, let's connect it to this cube. And in fact, I'm probably just going to remove all of the other parts because we don't really need them. And you can also highlight stuff and just click delete to delete it, which is fairly useful. And then it will cause errors with these, so just be aware. But it automatically deletes the mate connectors. So now we have this. Let's say, oh, dang it, I wanted this to have like the cube projected onto it or something. Which is, it's a very simple change. I could do it without. But whenever it's more complex parts, it's nice to have this. So now I can like create a sketch here, use this and be like, okay, I'm going to, now I can use, it's basically like it's another part. It's just kind of a phantom part. So you can use all of its features and stuff. But now I made that sketch and now I just want to remove this like 0.1. Then make sure it's going the right direction so it doesn't have the interference. And now you can see it's linked up and then this is changed. And if I go back to the assembly, it's changed like that. And then it'll show like the context one. And there's also, you can edit the context. update the context. So this is like the primary part right now. So that's what the context is based on. So if I go into here, it naturally hides the like main part. So it doesn't really help me adding it here. But let's say I wanted to change this part too. And like add this. Now if I go back here, this is changed because I added a part where the mate was. That always breaks. There's nothing you can do about that, but you can always just redo the mate. And now I'm like, hey, I want to update this context because now stuff has changed that'll affect it. I can update the context. If I go back in here, if you look, it's changed now because this sketch is now up here. So it's no longer going to extrude down into this part, into this part. It just doesn't intersect with anything. And this is where it can be nice if you want something to persist with changes to do it relative. So I can do up to face, and then we'll do an offset distance of 0.1, and then make sure it goes the right way. So now this offset distance is here. And if I go back into here, you can see there, it updated. And now let's say, oh, dang it, I want this to be longer. Let's make this 2 inches now. Before, we'd have to go back in and edit the sketch. Now, if we come in here and then update our context, which you don't technically need to update the context in this instance because it's still doing the same thing. But if we do update our context, it still persists because it was relative to this top face. So that's the gist of assemblies. And then the part studio in context, there's a few goofy things with that. If you're just making the part studio and then not updating it, you don't have to worry about it. But if you want to make it and then edit it later, so we have this. Let's create like a sketch here. Just a quick part. So now I have this new part. We can insert and go to assembly. It's very nice because you can just go right there. And it'll start here, but of course it's not mated together. So we can make a fastened mate here. Oh. That is the one annoying thing about how this whole set up. And you, by the way, I've been doing this like the entire time, but you can drag parts on this menu. And whenever you like exit out of it, they don't actually move. It's just for getting those mates done. So you can see this part's right here. And then, so this part studio 1, we can also update the context. And now, did it update? Well, I can go back to showing in context, but this one has not updated. Oh, wait, no. Sorry, I updated the context for this one. Whenever I made the part studio, it set this as the primary instance because there's only one. But like I can still update this context manually. And now it shows this. So if you do have multiple parts, you have to select which one's the primary instance. So like, let's say I want to make a little circle here and extrude it. And this is where, like, if you change the primary instance or you're editing multiple parts, that's where it can mess up whenever you update the context. So generally, I don't change the primary instance except for like setting it the first time. So it's, as you can see, this is not the primary instance. So I can set it as the primary instance. But now if I update the context, it's going to be relative to this part. So haven't updated again. But if we go back here, this is still fine right now. But now that I moved this part, everything's relative to this part. So if I update the context, go back to Part Studio 2, well, as you can see, this part has moved because it was relative, but if I hadn't set this relative to this part, so let's edit, let's go. This concentric mate is what locks it in place there. So now these are just two free floating circles. If I move this part around again, like over there, yep. Update context, context one. We go back here. This part's no longer on top here. So if I was using features from this, it would mess it up. And you can also see in the context, this part that's still in this part studio, it's shown here, but you can actually hide context instances. So that's pretty nice. So that's just pretty much all the stuff you need to know for assemblies and part studios in context. Now, mainly it's just practicing with them and getting better with the actual parts. But that'll be something you just kind of do on your own and learn about them. Then also experiment with the VexV5 library. It's really nice to test out connecting all of the different parts and actually using these features. So thanks, and I will see y'all probably Thursday this week for a recap video.